Valentine's Day, a special occasion where people express their sincere love towards one another by using different methods, from the heart-warming flowers to the cheesy love letters. However, what makes everything that I've spoken just now relevant to our topic?
I give my most pleasant greetings. Hello and good day to everyone. I am Alexa Isabel Sadariana, featuring grade Hyacinth, where I extend my hands towards you as we venture on with today's song. Graphing systems linear equation into two variables. With the use of technological advancement, rather than using a regular graphing calculator, we will be using its online application to aid us in today's video. So sit back and listen carefully as we aid you with today's problem. Given her a pair of linear equations. 2x minus y equals to negative 2 and 2x minus y equals to 4. For our problem, we will solve using both our digital graphing calculator and manual observation using one of the three methods of the graphing systems of linear equations of two variables, which is the slope-intercept method. Our first step is to graph the first equation. 2x minus y equals to negative 2. Use the slope-intercept formula for given the line. Y equals to mx plus b, where m is the slope and b is the y-intercept. 2x minus y equals to negative 2, this becomes negative y over negative 1 equals to negative 2x minus 2 over negative 1. We use the negative 1 to remove the remaining negatives of our answer in order to get the final result. Our final answer is y equals to 2x plus 2. Our slope is 2 over 1, where 2 is a rise and 1 is a run, and the y-intercept is 2. To rise and the run value of the slope and the y-intercept, we graph 2x minus y equals to negative 2 on the computational plane. You might be wondering, what is rise and run and how does it work? Rise means how many units move from up or down from point to point, and run means how far left or right you move from point to point. Our second step is to do the same things for the second equation. 2x minus y equals to 4. Use the slope-intercept form. Once you get the slope-intercept form, we cross out the negative 1 to remove the remaining negative of our equation and make it positive. 2x minus y equals to 4. Negative y over negative 1 equals to negative 2x minus 4 over negative 1. Our answer will now be y equals to 2x minus 4 with a slope of 2 over 1 with 2 being the rise and 1 being the run, and y-intercept is negative 4. Just like the first equation, use the rise and run value of the slope and the y-intercept to graph 2x minus y equals to 4 in the computational plane. We take out our graphing paper and mark it with points in its designated places. And we are now finished. Now let us try the same equations but on the graphing calculator this time. We have a visualized form of a T184 plus silver edition from Texas Instruments. But do not fret, as it still would function as it would realistic. Just like any other graphing calculator, this would be indifferent and have similar keys that will help us as we continue. We first have to turn the calculator on by pressing the on button on the farthest left corner. After we turn it on, we'll be greeted by a flashing caret at the top right indicating that we have turned the calculator on. We then go to the stat plot having the icon of y equals. Here we can see 10 spaces from y sub 1 up to y sub 0 to these are functions. Since we have two linear equations, we will only be using spaces. Y sub 1 equals and y sub 2 equals. We use the 4 arrow keys to navigate our way through. In the first space, we will type in our first equation but in the slope-intercept form. Y equals 2x plus 2. After we finish typing the first equation, we head to the second one by pressing the down arrow key so that the flashing arrow key is now flashing next to y sub 2 equals. We then type in y equals 2x minus 4. After we type in the two equations in, hit the graph button at the upper right-hand corner. We will soon be greeted by a coordinate plane, where the tick marks for x-axis extends from negative 10 to 10 by a scale of 1, and same goes for the y-axis. Since I have the equations given by Alan, the graph should display two lines within a parallel. Since our calculator does not distinguish the difference between the two lines, hence the color distinction, the line on your left is the first equation. Y equals to 2x plus 2, and the right one is our second equation, which is y equals to 2x minus 4. Hit the trace button next to the graph, and here you can see all the individual coordinates of both lines. Since our solution for the manual observation in the graph presented in our calculator is accurate, not only on the outside, but also in the solutions. We have solved the problem both manually and with the help of our graphing calculator. Now let us head back to see how both Alan and Elise are doing.